Hello everyone, you are welcome to today's class. Our topic today is resolution of forces. In our previous lesson on the principle of the parallelogram law of forces, we saw how the principle enables us to find the resultant of two forces acting at a point at an angle to one another. However, the reverse process can be carried out to convert a single force into two component forces. When this is done, the force is said to have been resolved into two components. For most practical purposes, a force is resolved along two directions at right angles. In England during the 18th and 19th century, a barge is used to transport goods along a canal by a horse. This was before the advent of railway. A barge is a flat-bottomed vessel which does not have its own means of mechanical propulsion in their days. The actual pull exerted on the barge is represented by the diagonal OR. The force to pull the barge along the canal is represented by the component OP. The force required to pull up the barge into the bank is represented by the component OQ. The diagram before you is showing a force F acting at an angle theta to the horizontal. F can be resolved into the horizontal component, which will be F cos theta. This will be the force required to pull the barge along the canal. F can also be resolved into the vertical component, which will be F sine theta. This will be the force required to pull up the barge out of water. Now, let's take an example. A motor vessel tows a small dinghy by a rope, which makes an angle of 20 degrees with the horizontal. If the tension in the rope is 15 Newton, find A, the force which will effectively pull the dinghy forward. B, the force which will lift it out of the water. Dinghy is a ship's smallest boat. As a rule, questions of this type may be solved either by scale drawing or calculation. We will take both. Let's take scale drawing. For scale drawing, it's better to have a sketch before constructing the diagram. We have a sketch before us. Looking at that sketch, the diagonal is the 15 Newton, which makes an angle of 20 degrees with the horizontal. For resolution of vectors, we will always use only the angle to the horizontal. For this question, we will take a scale of 1 centimeter represent 3 Newton. 15 Newton then will be equal to 5 centimeter. Draw a straight line AB with your protractor from a point O. Measure out 20 degrees. Draw a straight line making an angle of 20 degrees with the horizontal OP. Measure out 5 centimeter from O to P. Produce P down to meet line AB at R and join Q to P to complete the rectangle. The horizontal component OR represents the effective force to pull the dinghy forward. If correctly done, OR will be equal to 4.7 centimeter. Hence, the effective force will be equal to 14.1 Newton. Because when we multiply 4.7 by 3, which is our chosen scale, we will get 14.1 Newton. If you measure out PR, you will get 1.7 centimeter if correctly constructed. This is the part played by the vertical force. Converting 1.7 to Newton by multiplying by 3, you get 5.1 Newton. Now we want to solve the same question by calculation. We are going to resolve 15 Newton into the horizontal force, which will be F is equal to F cos theta. That will be equal to 15 cos 20 degrees. Cos 20 degrees is 0.9397. When you multiply that by 15, you get 14.0955, which is approximately 14.1 Newton. This is the force required to move the dinghy forward. Resolving 15 Newton into the vertical force will be F is equal to F sine theta. We substitute in our value, that will give us 15 multiplied by sine 20 degrees. Sine 20 degrees is 0.3420. Multiplying that by 15, we are going to get 5.13 Newton, which is approximately 5.1. This is the force required to move the dinghy out of water. I hope you enjoyed the lesson. If you have any question, please drop them at the comment section below. Do not forget to subscribe. Bye.